Greetings and welcome everyone into another episode. In today's episode, we will be discussing the ladder method. And basically, when we think about the ladder method is used to express a natural number as a product of its prime factors. So this method is used to express a natural number as a product of its prime factors. Yes. So what does this really mean? So when we think about the ladder method, one of the important items that we need to note is the process. And the most simple way to show the steps is to just dive straight into it. So let's take the number 36 as an example. So in the ladder, it consists of various steps, right? And these can go on depending on how many factors it takes to divide into your number. But the objective of this is to ensure that your quotient or your answer that is left is 1. So when I put this at the side, whatever number I have here at the top, ultimately as I divide by various prime factors, at the end I must be left with the number 1. And on my left hand side of this ladder there will be prime numbers here. Then whatever prime number I have here, this number must be divided by that smallest prime number. It will give me some value, call it V1. Then V1 must be divided by its smallest prime factor to give me value 2. Then this value 2 must be divided by its smallest prime factor, which is whatever it would be, to give me value 3. Then if value 3 divided by its smallest prime factor gives me 1, then I have successfully solved for my smallest prime factors, and I can express this number as whatever value multiplied by this value times that value. And most times you find things are common and so on, right? So that's basically the concept. So let's look at the number 36 and let's try to express this natural number as a product of its smallest prime factors, right? So when we think about this number 36, we know that we are dividing by its smallest prime factor. So already off the bat, we have to already ask ourselves, the prime factors that are at my disposal that I can use are what? Then we saw 2, 3, 5, 7, 11, 13, and so on, right? We saw in the previous video how to find the prime factors, how to determine them. Then these are the numbers at my disposal. Then let's see the smallest prime number that can go into 36. It's 2, right? So I put 2 there. Then 36 divided by 2. 36 divided by 2 is what? It is, maybe we can use orange here. It is 18. Then is 18 divisible by 2? Yes, it is. What is 18 divided by 2? It's 9. Then can 9 be divided by 2 without leaving a remainder? No, 2 is not a factor of 9. Then I go to the next multiple, which is the smallest multiple of 9. Which is sorry about that, which would be 3, right? Then 9 divided by 3 gives me what? Gives me 3. Then I go back. What number divided by 3? What's the smallest prime factor of 3? It's 3. Then 3 divided by 3 gives me 1. So if I had to express 36 as a product of its smallest prime factors, then it would be, or if I had to express 36 as a product of its prime factors, and 36 would be equal to 2 times 2 times 3 times 3. Or we could express this as 2 squared multiplied by 3 squared. And we all know that 9 times 4 is 36. Yes, it's very simple, right? Let's look at another example. And for this example, let's look at the number 90. Sorry, let's look at the number 98. So when we think about the number 98, we should ask ourselves, firstly we should present our list of prime factors. Then once you have your list, you identify out of my list of prime factors, what is the smallest prime factor that can be divided into 98, right? Or rather that 98 can be divisible by to give me a number without a remainder. Then I know that it's my number 2. Then 98 divided by 2 gives me, which number does it give me? It gives me 49. Then I have to ask myself, is 49 divisible by 2? Yes, it is, but it gives me a remainder, so I can't use that. So I need to go to the next, or its smallest prime factor. Then I have to ask myself, is 49 divisible by 3? Yes, it is, but it gives me a remainder. So therefore, then 3 is not a prime factor of 49. Then I need to go to my next prime factor. And what is that? It's 5. Then I need to ask myself, is 49 divisible by 5? Yes, it is, but does it leave a remainder? Yes, it does. Therefore, I cannot use 5. It's not a prime factor of 49. Then I go to my next number, which is 7. And I know that, yes, 49 is divisible by 7 without leaving a remainder. And what's the answer of 49 divided by 7? It is 7. then I know what number is divisible by 7 without leaving a remainder. Its smallest prime factor, that is 7. Because we know the factors of 7 are 1 and 7. 1 is not a prime number, so therefore the only prime factor or the smallest prime factor of 7 is 7. Then 7 divided by 7 gives me 1. Then if I have to express the number 98 as a product of its prime factors, it would be 2 multiplied by 7 times 7, which is basically 2 multiplied by 7 squared, right? And we all know that 2 times 49 is 98. Therefore, as well, this answer is correct. So lastly, this method is specifically used for very large numbers, right? So let's think about a number, and let's think about a number, what number can we use? Let's think about the number 1,800. Let's think about the number 1,800. So let's say we are being asked, using the ladder method, I want you to express the number Using the ladder method, I want you to express the number 1,800 as a product of its prime factors. Then once again, we know before we even use the ladder method, we firstly have to write out our set of prime factors, right? And of course, once again, we know how to identify prime numbers as we go past the number 13, so we can just refer back to that video. However, we know that in our list of prime factors, the smallest prime factor is 2. Then I have to ask myself, does this number 1,800, is it divisible by 2 without leaving a remainder? And that answer is yes. Then what's 1,800 divided by 2? It's 900. Then I have to ask myself, for the number 900, which is its smallest prime factor? What is the smallest prime factor that this number is divisible by, and that leaves a value without a remainder, and that's once again still 2. Then 900 divided by 2 is 450. Then I have to ask myself again, is the number 450 divided by 2 give me a number without a remainder? The answer is yes. Then what is 450 divided by 2? It is 225. Then is 225 divisible by 2? The answer is no, right? So yes, it is divisible by 2, but it leaves a remainder. So it's not, so 2 is not a prime factor of 225. Then I have to ask myself, then is 3 a number that I can use? Is it the next smallest? Is it the smallest prime factor of 225? If I say 225 divided by 3, yes, right? It gives me a value that, yes, doesn't leave a remainder. And what is that value? It is 75, right? Then I have to ask myself, okay, with this number, with this number 75, All right, so with this number 75, what is its smallest prime factor? Then can I say 75 divided by 3 and it doesn't give me a remainder? Yes, I can. And therefore, 75 divided by 3 is 25. Then I have to ask myself, if I take 25 divided by 3, will it give me a number without a remainder? The answer is no. Therefore, I have to go to my next prime factor. And what is that next prime factor? It is 5. Then, what is 25 divided by 5? 25 divided by 5 gives me 5, right? Then, lastly, what are the prime factors of 5? It's just 5, right? So 5 divided by 5 gives me 1. Then, how will I express 1,800 as a product of its prime factors? 2 times 2 times 3 times 3 times 5 times 5. And how can I write that more simply? It's 2 squared multiplied by 3 squared multiplied by 5 squared, right? Then we know 4 times 9 times 29, 4 times 9 times 25, of course, gives us, 4 times 9 times 25 gives us, made a mistake there. So I missed the 2 at the top. It's actually, let me erase that. So this is always something important to look out. How many 2's that I have there? It's 3, right? 2 times 2 times 2. And then times 3 times 3. Then times 5 times 5. And then if I write it more simply, it's 2 cubed multiplied by 3 squared multiplied by 5 squared. Then of course we know 8 times 9 times 25 gives me 1,800. Then this answer is correct. Then I hope we were able to see the use of the ladder method, and I hope it was very simple for everyone to follow. Please like and subscribe, and see you in the next video.